Imagine a world where your dream home builds itself piece by piece, transforming from a simple blueprint into a fully functioning abode while you watch. That's the astounding reality of self-assembling modular housing units, a futuristic technology poised to revolutionize the way we think about construction and living spaces. Before we dive in, don't forget to subscribe to our channel, like the video, and hit the notification bell, so you never miss an update on the latest in futuristic technologies. And feel free to share your thoughts and opinions in the comments below. Self-assembling modular housing units leverage cutting-edge technology to create homes that can autonomously assemble themselves using pre-manufactured components. These units are designed to snap together like pieces of a high-tech puzzle, creating a seamless and efficient construction process that's faster and less labor-intensive than traditional methods. Picture this: a truck arrives on site, unloading prefabricated modules that are then guided by robotic arms to fit perfectly into place. Within hours, what was once an empty lot transforms into a livable space. It's not science fiction, it's the future of housing. The concept of modular construction isn't new. For decades, modular homes have been assembled from prefabricated sections, offering a quicker and often more cost-effective alternative to traditional building methods. However, self-assembling modular housing units take this a step further by integrating advanced robotics, artificial intelligence, and smart materials to create homes that can literally put themselves together. This not only accelerates the construction timeline, but also significantly reduces the potential for human error. Imagine the potential for swiftly building emergency shelters in disaster-stricken areas or quickly deploying housing in rapidly growing urban environments. One of the key technologies driving this innovation is the use of smart material. These are materials engineered to have properties that change in response to external stimuli, such as temperature, light, or pressure. Shape. Memory alloys, for example, can return to a predetermined shape when heated, making them ideal for creating components that can self-assemble when exposed to certain conditions. Additionally, advancements in robotics and automation have enabled the development of robotic arms and drones capable of precise movements and assembly tasks, ensuring that each module fits perfectly into place. But what does this mean for the average homeowner or potential home buyer? For starters, the cost savings are substantial. Traditional construction methods can be labor-intensive and time-consuming, leading to higher costs. Self-assembling modular housing units, on the other hand, can significantly reduce labor costs and construction time, resulting in more affordable housing option. Furthermore, the precision and consistency of robotic assembly mean fewer defects and higher quality construction, giving homeowners peace of mind. Another significant advantage is sustainability. Modular construction generates less waste than traditional building methods, since components are manufactured in a controlled factory environment where material usage can be optimized and waste can be minimized. Additionally, the energy efficiency of these homes is often superior due to the precision assembly and the integration of smart technologies that can monitor and manage energy use more effectively. Imagine a home that not only builds itself but also optimizes its maintenance and energy consumption, contributing to a more sustainable future. Now, let's delve deeper into the technological aspects that make self-assembling modular housing a reality. At the core of this innovation is artificial intelligence. AI algorithms can design the optimal configuration for each module, ensuring that the finished structure meets all design and engineering specification. These algorithms can also adapt on the fly, making real-time adjustments to the assembly process to account for unforeseen challenges or changes in the environment. Robotic systems play a crucial role as well. Imagine robotic arms equipped with sensors and cameras working in tandem with drones, each component communicating with the others to ensure precise placement and alignment. These robots can operate around the clock, tirelessly assembling the modules with a level of precision and speed that surpasses human capability. And because they are controlled by AI, they can learn and improve over time, becoming more efficient with each project. Additionally, advancements in 3D printing have paved the way for the custom fabrication of modular components. Using high-strength, lightweight materials, 3D printers can create complex geometries and bespoke designs that were previously impossible or too costly to produce. This means that each self-assembling modular housing unit can be tailored to the specific needs and preferences of the homeowner, offering a level of customization that traditional construction methods can't match. But what about the safety and durability of these homes? After all, a home that assembles itself doesn't do much good if it can't withstand the test of time and the elements. Fortunately, self-assembling modular housing units are designed with these concerns in mind. The materials used in construction are often more durable and resilient than those used in traditional home. For instance, composite materials that combine the best properties of different substances can offer superior strength, durability, and resistance to environmental factors like moisture and temperature fluctuation. Furthermore, the precision of robotic assembly ensures that each module is perfectly aligned and securely fastened, reducing the risk of structural weaknesses. In addition, ongoing advancements in material science are leading to the development of self-healing materials that can repair themselves when damaged, further enhancing the longevity and resilience of these homes. From a design perspective, the possibilities are virtually limitless. Self-assembling modular housing units can be configured in a variety of ways, offering everything from compact, minimalist living spaces to expansive, multi-level homes. The modular nature of these units means that they can be easily expanded or reconfigured as the needs of the homeowner change. Imagine starting with a small one-bedroom unit and then seamlessly adding additional modules as your family grows. The flexibility of this approach makes it an ideal solution for a wide range of housing needs. The impact of self-assembling modular housing units extends beyond individual homeowners. Urban planners and developers are also recognizing the potential of this technology to address some of the most pressing challenges facing cities today. For instance, the rapid pace of urbanization has led to a growing demand for affordable housing in many parts of the world. Traditional construction methods simply can't keep up with this demand, leading to housing shortages and skyrocketing prices. Self-assembling modular housing units can be quickly and efficiently deployed to address these shortages, providing much-needed relief to growing urban population. Moreover, the ability to swiftly assemble housing units makes this technology ideal for disaster response. In the aftermath of natural disasters, providing shelter for displaced individuals is a critical priority. Self-assembling modular units can be rapidly deployed to provide safe, durable housing in a matter of hours or days, rather than weeks or months. This capability has the potential to save lives and significantly improve the quality of life for those affected by disasters. Another exciting application is in remote and challenging environments. Traditional construction in remote areas can be logistically challenging and expensive due to the need to transport materials and labor to the site. Self-assembling modular housing units, on the other hand, can be transported in compact, easy-to-handle modules that require minimal on-site labor for assembly. This opens up new possibilities for creating housing in remote areas, from research stations in Antarctica to eco-friendly resorts in the heart of the rainforest. But the potential of self-assembling modular housing units doesn't stop at residential applications. This technology can also be applied to commercial and industrial construction. Imagine office buildings, schools, hospitals, and factories that can assemble themselves in a fraction of the time it takes to construct traditional buildings. The efficiency, cost savings, and flexibility offered by self-assembling modular construction could transform a wide range of industries, making it possible to rapidly respond to changing needs and demands. As we look to the future, it's clear that self-assembling modular housing units have the potential to redefine the way we think about construction and living spaces. This technology offers a host of benefits, from cost savings and sustainability to flexibility and resilience. While there are still challenges to overcome, such as perfecting the technology and ensuring regulatory compliance, the progress made so far is incredibly promising. In conclusion, self-assembling modular housing units represent a remarkable leap forward in construction technology. By harnessing the power of artificial intelligence, robotics, smart materials, and 3D printing, We are paving the way for a future where homes and buildings can build themselves. This innovation promises to make housing more affordable, sustainable, and adaptable to the ever-changing needs of our world. So, as we stand on the brink of this exciting new era, it's thrilling to imagine the possibilities that lie ahead. Thanks for joining us on this deep dive into the world of self-assembling modular housing units. Don't forget to subscribe to our channel, like the video, and hit the notification bell so you never miss out on the latest updates and insights into futuristic technology. We would love to hear your thoughts and opinions on this revolutionary technology, so please share them in the comments below. Until next time, stay curious and keep looking to the future.